Video for the pre-test. I'm going to try to do these as quickly as possible so these videos are as short as possible. The first one, we got a triangle, and I'll find the perimeter first on each one, then I'll find the area. So you got perimeter, and you got area on the first one. To find the perimeter, we just add up all the sides, so that's 8.5 plus 8 plus 10. Make sure you got your calculator handy. 8.5 plus 8 plus 10, and that gives you 26.5. Don't forget your units, that's feet. That's for the perimeter of the first one. Area, the formula for area of a triangle is 1/2 times base times height. Well, the 1/2 will probably change to 0.5 this time. This is the base of the triangle. Remember, it's wherever that right angle is sitting. So that's times 10 times the height. This is the height, that's also the altitude. We multiply all that together and you get that the area is 35, and don't forget your units. For area is always feet squared. Number 2, find the perimeter of number 2. This is a square. You should be able to tell it's a square because it's got 4 sides, got right angles, all the right angles in it, so it's a square. So all we do is take 3.4 times 4, or add up 3.4 4 times, and you end up with 13.6 meters. Then the area, formula for area of a square, you can use the length times width for a rectangle, or you can just do s squared. Punch in 3.4 squared on your calculator. 3.4 times 3.4, and you end up with 11 point, and they told us round it off to the nearest tenth, so about 11.6 meters squared. Next one's a rectangle. Find the perimeter. We just add up all the sides, usually with a rectangle, because they just give you 2 sides. What I do is I add those 2, then multiply by 2. We add those 2 together and multiply that answer by 2, and you end up with 55, and our units are kilometers. Remember, perimeter is just regular units, area is always squared units. Formula for area of a rectangle, length times width. This time the length and the width are 18.5 and 9, so we just multiply those 2 together, and when you multiply those 2 together you get 166.5 kilometers squared. Number four, these tick marks tell us that we have an equilateral triangle. There's 2 different ways you could do this. You could draw in the altitude and know that this is a 30, 60, 90 triangle, and use that. The side across from the 30-degree angle should be labeled L, side across from the 60, L times the square root of 3, and the side across from the right angle is 2L. Well, that 2L side over there is 4. So you could use all that. To find the perimeter, we actually just have to multiply one of the sides by 3. So 3 times 4 is 12 meters. The other way you could find the area, because you could use 1/2 times base times height. Well, we'd have to draw in that altitude, like I was saying, to find the height. Or you could use the formula that's on the formulas packet for a equilateral triangle, which is the square root of area equals the square root of 3 divided by 4 times s squared, where s is the length of a side. I use this one instead of the base times height. Instead of finding this height, it doesn't really matter which one you use. So I punched in my calculator square root of 3, hit equals, then divided by 4, hit equals, then put in 4 for s, and hit times 4 squared, and it ended up giving me, on my calculator, it gave me 6.9 meters squared. The next one, I should have told you on this one that this one is a rectangle. So we have this rectangle, and the thing I wanted you to be able to pick out on this one is that if this side's 7 and the hypotenuse is 25, then this side over here has to be 24, because it fits into that 7, 24, 25 Pythagorean triple or family. To find the perimeter, We know that that side's 24, that side's 24, that side's 7. We add all those up, and you end up with a perimeter of 62, and our units this time were inches. Again, make sure you don't forget your units on any of these. Area for a rectangle, we just, excuse me, take length times width or base times height. So 7 times 24, grab your calculator and do that. You end up with 168 inches squared. Main thing on that one, you got to be able to pick out some of those families to make things easier on it. Same thing on this one, sorta. This is a 45, 45, 90 triangle. Anytime you draw a diagonal in a square, you got a 45, 45, 90 triangle. 45, 45, 90. Sides across from the 45-degree angles are labeled L and L. Side across from the right angle, the hypotenuse, is L times the square root of 2. Well, we look at that right there, and if that diagonal is 10 radical 2, and it's supposed to equal L radical 2, then that means L has to equal 10. If L equals 10, then we know this side's 10, 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 so the perimeter is going to be, all those add together, which is 40, what was our units, meters. And the area, to find the area of a square, again, you could use S squared for the formula, or you could use length times width, base times height. It doesn't matter which one of those you use. S squared is the one I use. So it's just 10 squared, which is 100 meters squared. Number seven, when you look at this, it didn't tell you this, but you should know this. When the diagonals bisect each other and they're perpendicular, then you should know that that's a rhombus. Formula for a rhombus, for perimeter, oops, I forgot to write in a number. For perimeter, we know that all the sides are equal, so all we got to do is take one of those sides and times it by 4. So the perimeter is just 4 times 22.4, and when you do that, you end up with 89.6. And again, remember your units are just regular units, so 89.6 meters. For area, the formula for area of a rhombus is 1/2 times diagonal 1 times diagonal 2. You could also use base times height for a parallelogram, because a rhombus is a parallelogram, so you could also use that. Here I'm just going to use this one instead, so I got 1/2 times one of the diagonals is 40. The other diagonal, got to add these two together, is 20. You punch all that into your calculator, and you end up with the area equals, comes out to be 400 meters squared. That's the area. Next one, we got a trapezoid. To find the, and they tell us it's an isosceles trapezoid. To find the perimeter, we know that this side over here is 17.5, because if it's isosceles, the two legs have to be the same. We add all those up, and you end up with 85 feet. If I mess up any of these, please tell me during class at some point if you see any of them that I messed up on, because I'm sort of rushing. Next one, for area, the formula for area of a trapezoid is 1/2 times height times base 1 plus base 2. Remember, the bases are the two sides in the trapezoid that are parallel to each other, so it's those two. So this one's going to be 1/2 times, the height is right here. Again, when we get to the three-dimensional figures, don't get the heights of them confused with the height in a two-dimensional shape. So the height this time is 16 times base 1, we'll put in 18, and base 2, we'll put in 32. You punch all that into your calculator, and you end up with the area equal to, same as the last one, confused myself, 400 feet squared. Next one, you have a regular hexagon. Formula for perimeter of a regular hexagon. You just count up the sides, 1, 2, 3, 4, 5, 6 sides. So for the perimeter, we're just gonna take one of the sides times 6. So we just take this 8 right here and times it by 6. Well, 8 times 6 is 48 centimeters. That's the perimeter. For area, the formula is 1/2 times big P times little a. Remember, big P stands for perimeter, little a stands for apothem. So we got 1/2 times big P we just found right above there is 48. And little a is the apothem. Apothem, remember, goes from the center to the midpoint of one of the sides. So that's 6.9. You punch all that into your calculator and you end up with the area equals 165.6 centimeters squared. Number 10, yeah, you have a parallelogram. They tell you it's a parallelogram. Find the perimeter of a parallelogram. You just add up all the sides in a parallelogram. Opposite sides have to be equal, so this side has to be 4.7, this side has to be 9.4. We can find the perimeter of that, add all those up, and the perimeter ends up being 28.2 feet. It's 28.2 feet. That's a decimal there. And the area, formula for area of a parallelogram is base times height. Well, the base is where the right angle sits. That's this side. The height is that altitude right there. So we just do 9.4 times 4.3. Multiply those together on your calculator and you end up with 40.4 feet squared. Next one, we got this strange shape. To find the perimeter, first thing we got to do is find the lengths of these sides that we don't know. This one here is pretty easy. It's got to be the same as that one, so it's 4. This one here is the same as this one over here, so it's 2. This one and this one, along with this one, all have to add up to 7. So we don't really know the length of each one of these, but we do know that 3 plus 4 gives us 7, so these two together have to add up to be 7. I'll just make this one 1 and this one 3, and then we have a total of 7 all the way across through there. 1 plus 3 plus 3. We don't know for sure that each one of those, that one's 1 and one's 3, but we do know that that's the way they have to be total up. If we start adding here, we start here, we go 3 plus 4 is 7, plus 3 is 10, plus 2 is 12, plus 7 is 19, plus 2 is 21, plus 1 is 22, plus 4 is 26, so 26 millimeters is our perimeter. Our area, we don't have a formula for area of a shape like this, but if we split it up into 2 rectangles, we have that top rectangle, it looks like that. It's 7 units long, 2 units wide. The area is going to be 14. Then we have the rectangle goes up and down, this one right here, and it's 3 wide and 4 tall, so that's going to be 12. And our area ends up being 26 millimeters squared. Every now and then you get one where the perimeter and the area have the same number, but they're different units. Next one, number 12. To find the perimeter of this, we know that this part is 34, this part's 15, that part down there has to be 34, but we don't know this. Well, the way we find that, to find the perimeter, is we take pi times diameter. That's the perimeter, or the circumference or perimeter of a circle, but we don't want the whole thing, so we just multiply it by 2, or divide it by 2, sorry. Well, our diameter this time is the same as this over here. That diameter right there is the same as this side, so that diameter is going to be 15. So in your calculator, you just punch in pi times 15, then divided by 2. That's going to give you this, and it comes out that that is about 23.6. Then all we do is add that 23.6 in all 3 of these, and you end up with a perimeter for that one of 106.6 feet. Then for area this time, we're going to find the area of this rectangle and then add it to the area of that half circle or that semicircle right there. Well, the area of the rectangle is just going to be 34 times 15, and the area of the rectangle ends up being 510, plus, then to find the area of the circle, we do pi times radius squared. Well, the radius, we got to take half of 15 to get that, so it's pi times 7.5 squared. You punch all that into your calculator, and you end up getting something about 88.4. And to find the total area, we're just going to add those two together, and we end up with 598.4 feet squared. So that's our area. Don't forget feet squared there, and that's our perimeter of that crazy looking shape. Number 13, we got a circle. Find the perimeter or circumference of a circle. Use pi times diameter. Well, they tell us the radius this time, so to get the diameter, we just have to double that. So it's just doubled is 22 times pi. And again, I told you could leave your answer that way. This says round your answer to the nearest tenth though, so if you wanted to change it to a decimal, it ends up being 69 point, if you punch it into your calculator, 69.1 centimeters. Area, don't forget area of a circle. It's just pi times radius squared. Well, this time the radius is 11, so it's going to be pi times 11 squared. If you punch all that into your calculator, you end up with 380.1 centimeters squared. Number 14, on number 14, the main thing I want you to pick out on this one is we have to know this. We have to know that diameter. Well, that's in a right triangle, and one of the sides is 5, another side's 12. Well, then that means that hypotenuse has to be 13 because it fits in that Pythagorean triple or that Pythagorean family, and you could have used Pythagorean's theorem to find that also. So we now know that the diameter is 13. Well, that means the radius is 6.5. To find the perimeter or circumference, we're just going to take that 13 times by pi, because it's pi times diameter for circumference. And if you punch all that into your calculator, you end up with 40.8 centimeters. That's your perimeter. Area is pi times radius squared, just like on the last one. So we punch in pi times 6.5 squared. If you punch all that into your calculator, you end up with 530.9 centimeters squared. Number 15, we have an ellipse. To find the perimeter of an ellipse, we got this big long formula. Look it up on your formulas worksheet. It's 2 times pi times radius 1 squared plus radius 2 squared divided by 2. So if you look that up on your formula sheet, remember this is radius 1, that's radius 2. It doesn't really matter which one's which. So all we're going to do is plug in 5 right here for radius 1 and 7 for radius 2. And you got to do some of this separately. If you try to punch all this into your calculator, it's probably going to mess up. So what I usually do is do all the stuff under the radical here first, and I get 2 times pi times, if I do all this under the radical, 5 squared is 25, 7 squared is 49, 25 plus 49, you can add that up on your calculator, and you get 74. Then you take 74 divided by the 2 right here, and you end up with 37. And if you take 2 times pi times 37, the radical 37, you can punch all of that right into your calculator and just do 2 times pi times the square root of 37, and you end up with 1 you end up with a perimeter that's about 38.2 meters. For area, the formula for area of an ellipse is just pi times radius 1 times radius 2. Our radius 1 this time is 5, our radius 2 is 7. So you just punch into your calculator pi times 5 times 7. And you end up with an area of about 110.0 meters squared. Again, if I mess up on any of these, please tell me during class, because I'm running through these and I'm doing them as I go on this video. So, and I'm hurrying, so I may very well mess up on them. On number 16, we have a square pyramid because the base is a square and all the other faces are triangles, so it's a square pyramid. To find the surface area, what you're going to have to do is separate all the faces off and find the area of each one of them. Well, since it's a square pyramid, our base is a square and it's 10 by 10, so that's one of the faces. Our other faces are 4 triangles, but the nice thing about this one is if it's a square pyramid, we know all 4 of those triangles, even though mine don't look like it, all have the same area. So all we got to do is find the area once. And remember the formula for area of a triangle is 1/2 times base times height. Well, in each one of these triangles, this is 10. That's inches. That's 10. And then what comes down the side of the pyramid is called the slant height. And that slant height this time is 14, they tell us. So up here, area of the square is going to be 100. Area of the pyramid, or of the triangle, sorry, is 1/2 times 10 times 14. And we could do half of either one of these and then take it times the other one. I'm going to take half of 14 and get 7. Then 7 times 10 is 70. So the area of that triangle is 70. Well, since it's a square pyramid, that means all of them are 70. And to find the surface area, we just add all those up. 4 times 70 is 280. 280 plus 100 is 380. And our units are inches squared. Don't forget, even for surface area, still square units. Then for the volume, you look up the formula on the formulas worksheet for volume. And for a pyramid, volume is 1/3 times big B times H. Don't forget big B, same as with the prisms. The big B stands for the area of the base. Well, we just found the area of the base. So you're going to grab your calculator and you're going to take 1/3 times 100 times, now this here, the 14 was the slant height. So what you actually have to do is you have to find the actual height of the pyramid. And the height would be like if you were standing up at the point and you dropped the rope straight down, it would go right down to the middle of that pyramid. And it shows you on the picture there. I know I didn't draw the picture, but it shows you on there. So what we have to do is we have a triangle. This is our slant height. We have the bottom down here, which is halfway across the pyramid, so that's going to be 5. And then we're looking for this, and we're just going to use Pythagorean's theorem on that. So we do 5 squared plus x squared equals 14 squared. You do the 5 squared, you get 25, plus x squared equals 14 squared. Grab your calculator, and 14 squared is 196. Then you subtract 25 on both sides, and you end up with x squared equals, 171. I'm running out of room down there, so I'm going to do this. X squared equals 171. Then you got to take the square root. So square root of 171 is about 13.1. So this side right here is 13.1. That's the height of the whole pyramid. Oops, 13.1. Then we multiply all those together. 1/3 times 100 times 13.1. It might even be easier if you just did big B times H divided by 3. That means the same thing. So if I do big B, that's 100 times 13.1 equals, and then divide that by 3, and I end up with the volume of 436, about 436.7 or 436 2/3. And remember, for volume, it's inches cubed. Inches cubed. Number 17, we just have a rectangular prism. Rectangular prism's a little easier. For surface area, we're just going to find the area of all 6 faces. Well, all 6 faces are rectangles, so I'm just going to draw 6 rectangles. Since it's a rectangular prism, these 2 are the same, these 2 are the same, these 2 are the same, so we're only going to have to find the 3 of them. And if we just label them, the front face there looks like it's 18 by 8. That means this other face is 18 by 8. Then that side face looks like it's 16 by 8. And that means the other one's 16 by 8. And then the top and the bottom, the bottom is 18 by 16. And that means the bottom's 18 by 16. Grab your calculator and multiply those together. So this is what I got on each one: 144 on the top 2, 128 on the second 2, 288. When I multiply these together on the third ones, then to find your surface area, you add all those up and you end up with 1120. And our units on this one were centimeters, so it's centimeters squared. Then to do the volume's the easy one. It's just length times width times height for a rectangular prism. So our length, width, and height are 18, 16, and 8. Doesn't matter which order they go in. Grab your calculator, you multiply all those together, 18 times 16 times 8. And you end up with a volume of 2,304, and our units are centimeters cubed, not squared, cubed. On the next one, we have a cylinder. Now, it's a special kind of cylinder, but just treat it like it's a normal cylinder. And we won't talk, we'll just deal with normal cylinders. So treat it like it's not slanted. So we have that cylinder. And on a cylinder, surface area formula is 2 times pi times radius times height plus 2 times pi times radius squared. On this one, they didn't give you the height. Or yeah, they did give you the height of the cylinder, 5 inches, and they gave you the radius is 3. Those are the only 2 things we need, so we just plug into this formula. Surface area equals 2 times pi, the radius this time is 3, times the height, which is 5, plus 2 times pi times the radius, which is 3 squared. You can punch all of that right into your calculator, just like it is right there, and it'll give you the answer. When I punched it in my calculator, I got 138.1 inches squared. Remember, your units for surface area is always square units. So that's our answer, 138.1 inches squared. One thing on this, don't forget that this right here is the 2 circles, the top and the bottom of the cylinder. This is the round face, or the outside of the cylinder, and if we cut it and laid it out flat, it would be a rectangle. Then to find the volume, you look up the formula for volume on your formulas packet. Volume for a cylinder is pi times radius squared times height, and all we're going to do is plug into that. So it's pi times our radius was 3 squared, the height was 5. You punch all that into your calculator. So you got pi times 3 squared times 5, and you end up with 141.4, and our units are cubic units for volume, so inches cubed. On number 19, you have a cone. If you look up the formula for surface area of a cone, there's actually 2 different formulas that you could use. The first one that I have written up here, you need to know the radius and the slant height. That's what the S stands for, so that'd be the height going up the side of the cone. The second one, you need to know the radius and the height. That's the height going straight down the middle of the cone. Well, that's what we know this time, so I'm going to use this second one. So it's going to be pi times, and this time they told us the radius. Oh no, I'm sorry, they didn't tell us the radius on this one. They actually told us a degree there, so I better draw this. We have a triangle, and they tell us that this is 66 degrees. And we know that this right here is 18 millimeters. So we can use SOHCAHTOA to find that. Whichever we want to find, whether we want to find the radius, I'll just find the radius since I already started using that one. That's your opposite leg. This over here would be your hypotenuse, but and we could find it and just use this formula. But we'd also have to find this radius, so either one, we could, let's just go ahead and we'll just find both of them and we'll use this top formula, because the top formula is a little easier. So you could use this formula, but we won't this time. So we won't use that formula this time, it's a little longer. So here we do, that's our opposite, that's our hypotenuse, this is the adjacent. We want to find the adjacent, that's actually going to be the radius of our cone. So I set up adjacent and opposite, that's tangent of 66 equals 18 over r. Grab your calculator and you find the tangent of 66. I come up with I come up with 2.2460. That equals 18 over r. Put a 1 underneath that, cross multiply, and you end up with 2.2460 times r equals 18. Divide both sides by that 2.2460. These are going to cancel, and it's just going to leave you with r. That's going to tell us what the radius of that cone is. So 18 divided by 2.2460, and we end up with about 8.0 is the radius. So the radius of this cone for this one is r equals about 8.0, or just 8. And then I set up the same thing almost, only this time I'll use the hypotenuse in the opposite, which in our SOHCAHTOA is the sine. So I do the sine of 66 equals opposite over hypotenuse. The hypotenuse this time is our slant height of the cone. So it's going to be 18 over s. Punch in your calculator, find the sine of 66. You end up with 0.9135 equals 18 over s. Put a 1 underneath that, we cross multiply, and when you cross multiply there, you're going to do a whole bunch of stuff, and you're just going to end up finding s, and I'm going to just do it on my calculator here. So we end up with 18 divided by 0.9135, and I end up with about 19.7 is the slant height of that cone. So if you have your cone, that's our cone. The slant height is going right up through here. This coming right down the middle, that's just your regular height, and then that right there is your radius. So if I plug into this formula right here, I end up with pi times radius squared, which is 8.0 squared, plus pi times radius, which is 8.0, times the slant height, which is 19.7. You can punch all that right into your calculator just that way and get your answer. When I punched all that in, I end up with the surface area equals about 696.2, and our units this time were millimeters, so millimeters squared, 600, that's the surface area. And for volume, look up on the formulas packet that I gave you, volume of a cone, and it says the volume, it gives you, it's not really two different formulas, just written two different ways. It's 1/3 times pi times radius squared times height. Another way you could write that is pi times radius squared times height divided by 3. That might be easier. We've got pi times our radius was 8.0 squared times the height. They told us the height, and the height was 18 millimeters. So times 18, that's this height, that's not the slant height. Divided by 3, is punch all that into your calculator. When I did that, I ended up with the volume equal to 1,206.4, and it was millimeters, and when it's volume, it's millimeters cubed. Millimeters cubed. This was supposed to be problem 20. Sorry, that was problem 20. That was problem 20. I'll do 19 now. Problem 19. Problem 19. They give you what looks like a hexagonal prism. And it looks like it's a regular hexagonal prism. I'm just going to draw one of the hexagons, sort of. They tell us that this side is 2 feet. And they tell us that the length of the hexagonal prism back through here is 11 feet. We had a whole bunch of, we had like 3 different formulas to find the area of a regular hexagon or a regular octagon or pentagon or any regular polygon. We had like 3 different ones, and you could, just knowing the 2, use one of those other 2 formulas. I'm actually going to find the apothem here. If we want to find this A right there so that we can use that to find the area of that, so that we can find the surface area of the whole thing, I'm going to do that. Remember, this is a right angle. Since this is a hexagon, this angle up here, we figured out all the angles add up to 720, so each one's 120, and that ends up making this right here a 30, 60, 90 triangle. And this comes down here and it bisects this side, so that right there is 1. So side across from the 30-degree angle should be labeled L, so that tells us that L equals 1. Well, then that means this side, that apothem right there, which is across from the 60-degree angle, should be L times the square root of 3, or just 1 times the square root of 3. So the apothem this time is 1 times the square root of 3, or just the square root of 3. So we can use that and plug in. When we're finding the surface area, to do the surface area, all we're going to do is find all of these faces. Well, we have 2 hexagons, and they're both identical, if I could draw them, which apparently I can't. They're both identical. Then we got 6 rectangles. And since this is a regular hexagonal prism, all 6 rectangles are the same. So all we actually have to do is find the area of one and multiply it times 6. To find the area of this hexagon, we do 1/2 times big P times A. Big P is the perimeter. They told us each side was 2, so we just take 6 times 2, that's 12, so we got 1/2 times 12 times the apothem, which we figured out was the square root of 3. You plug all that into your calculator, you can change the 1/2 to 0.5, so 0.5 times 12 times the square root of 3, and you end up with about 10.4. So the area of that hexagon right there is 10.4. That means the area of the other base, which is the other hexagon, is 10.4. And then we look at each rectangle. Each rectangle comes down through here. Well, the length of those rectangles, for a rectangle, the area is just length times width, or base times height. The length is 11, and the width is one of the sides of the hexagon, which is 2. 11 times 2 is just 22, so this rectangle is 22, that one's 22, that one's 22, that one is, and that one is. So we're going to add all that up to get the total surface area. So 10.4 plus 10.4, and then plus all the 22s, all 6 of them. And I ended up with surface area for this shape, for this hexagonal prism, of 152.8, and our units were feet, so it's going to be feet squared. Then for the volume, remember, look up the formula for volume of a regular polygon, a regular prism, and let's see, I know it's on here somewhere. On the formulas worksheet, it says other prisms, and the volume is just big B times H. Remember, the big B is the area of one of the bases. Well, we just found that. It's 10.4. So it's 10.4 times H. Remember, the H, the height, isn't this height. It's the distance from one base to the other. So in this case, it's 11. So we just take 10.4 times 11. And you end up with volume of 114.4, and your volume's always in cubic units, so it'd be feet cubed. That's all I have time to get done. So this is for the pre-test. If you watch this, that'll help a little bit. Hopefully we'll have some time to go over maybe a couple more in class.